It is in this lesson that we are going to first start learning how to factor expressions. It's a skill that we'll find is very important and very useful for us, and it's something that we're going to spend a lot of time developing. Before we get into the actual factoring itself, there's some concepts that we want to be able to recall that will be very helpful for us. Some things that even go back to like elementary school. So first of all, recalling what a multiple of a number is. A multiple of a number really can formally be defined as taking a natural number times the number itself that you want to find multiples of. So for example, if we're wanting to find multiples of 12, it turns out that the smallest multiple of 12 is actually 12 itself. So you start by like multiplying by 1, and then you can multiply by other natural numbers like by 2 and by 3 and by 4, etc. So that gives us a list of multiples of the number 12. So if we're trying to find factors of a number, it's basically just kind of the reverse, in that they are going to be numbers that are smaller or equal to that can multiply by a natural number to equal that particular number. Or in other words, you're able to divide by the factors and not have a remainder. So for example, factors of 12 are going to include the number 1, because you can do 1 times 12, and then of course 12 has to be a factor as well. Other factors include 2 and 6, because 2 can times with 6 to equal 12, and then you also have 3 and 4 are factors, since 3 times 4 is 12, and those would be the only factors. So when we're looking for factors, we really just want to keep them as just whole numbers. So there ends up being a total of 6 factors there for the number 12. All right, so now we're going to get into this realm of kind of factoring expressions. So to write something in a factored form means that you write whatever it is, the number, the expression, so that it is a product of some of its factors. So writing something in factored form means to write a product of factors. So you'll see what I mean through examples here. So in this first example here, we're asked to write 12 in factored form. So it means we want to write a product of factors to equal 12. So one, I guess, correct answer would be to write 1 times 12, and that would be a factored version of 12 because it's a product. So note that this would be wrong if I wrote like, I don't know, 11 plus 1, because that's not a product, right? That's a sum. So you want the entire expression to just be only multiplying, and then that would be something that's in a factored form. So 1 times 12 isn't really the only correct answer, I guess. You could say 2 times 6 is a factored form, and you could also say that 3 times 4 is also a factored form. Now, once we get into factoring more, we're going to always want to factor so that we break it down to the smallest possible numbers that we possibly can. So even though I kind of have 3 correct answers, 3 things that are factored, the best answer is when we break things down all of the way. So like if I take the 3 times 4, because I know 4 is like 2 times 2, I could make it 3 times 2 times 2, right? And that still equals 12. But then you can't break down 3 or 2 any further because they're all prime. So this right here would actually be kind of the best factored way of factoring 12 when you can break it down. And it turns out that every number actually breaks down to just prime factors. So the same thing would happen with the 2 and the 6, because we know that 6 is 3 times 2. You get 2 times 3 times 2. And then if you did the 12, like you could do, I don't know, 1 times 2 times 6, but then that 6 is, right, 2 times 3, so you'd have 2 times 2 times 3. So no matter what, like when you break it down, it's just ultimately going to always break down to the same product of factors. So if we're asked for a prime factorization, something that you also kind of learned about back in the day, you might have used like factor trees to try to even figure some of this sort of stuff out, right? So like if you were to try to prime factorize 525, it just basically means break it down all of the way. So like 25 is going to go in what? Like 21 times, I think. So like 25 times 21 is equal to 525. But then you would know you could break down like 25 into 5 times 5, but then you can't break that part of the tree down any further because both of those numbers, they're both 5s, are prime. And then 21 you could break down into 3 times 7, but both 3 and 7 are prime. So all of the ends of the trees are going to be the prime factors that then when you multiply them all together is actually just still going to equal 525. So it turns out that 5 times 5 times 3 times 7 would be a factored form, but actually the prime factored form of the number 525. And then the last example here says to factor 19, but 19 is prime, right? Like it's not divisible by any other natural number. So if you're going to factor 19, really, I don't know, you just keep it as 19 because there's 19 times 1. In other words, you're not actually able to factor it. So one thing we might say about prime sorts of things, it's not really factorable, so you just kind of have to leave it as 19. You're not able to actually write it really as a product of factors. So something that also that you've probably learned about previously is something that's called a GCF, or a greatest common factor of an expression, right? And ultimately what a greatest common factor is it has to be a factor, so it has to be a number that multiplies into a number nicely, right? But you have to look for common factors, so things that they share, but look for the one that is the absolute greatest, right? So if we're asked for a greatest common factor of 18 and 24, for example, we'd want to try to find factors, but ones that they have in common, and then find the one that's the greatest, right? So if we find factors, first of all, the factors of 18 turn out to be 1, 2, 3, 6, 9, and 18, because 1 times 18, 2 times 9, and 3 times 6. And then for 24, it turns out to be 1, 2, 3, 4, 6, 8, 12, and 24 for the factors of 24. Then we'd want to identify any ones that they have in common with each other, which would be 1, 2, 3, and 6 are the only ones they have in common, and then you just find from there, of course, the greatest, and the greatest of the ones that they have in common would be the 6. So it does turn out that the GCF of 18 and 24 is equal to the number 6. If we were to jump to the next example, of course, you'd have to list out all the common factors of 16 and 32 and 54, and then find the one that's the greatest. It does actually turn out that the GCF, if you worked it out and you want to check it, it's actually just 2. That's the largest number that they have as a common factor.